Hi, I'm Garcia-knab from Harmony Schools and welcome to my Galileo versus Aristotle video. In this project, we want to find out if it was either Galileo or Aristotle that was right in terms of their free fall theories. We also want to find out if the mass of an object will affect the rate at which it free falls towards Earth's surface. Aristotle believed in a more general idea that the like elements would attract. This includes air, fire, earth, and water. For example, steam would climb up from the earth because it was made out of air. And then the earth was made out of a different element, so those two repelled each other. In terms of physics, he believed that the heavier the object, the faster it would fall than the lighter one. Galileo, however, believed that the speed of a freely falling object only depended on the time of the fall, not on the weight of the body. He also believed that because of air resistance, the heavier object would fall faster than the lighter object. Without air resistance, both of them would fall at the same time. Now let's put this into perspective. Aristotle's law predicts that a 1 pound ball will take 10 times longer to free fall. Let t equal time required to travel a given distance, and assume that v is inversely proportional to t, to where greater the speed equals the less time of the fall. Now v1 is going to equal speed of the 1 pound ball, and t1 is going to equal the time for the 1 pound ball to hit the ground. And v2 is going to equal the speed of the 10 pound ball, while t2 is going to equal time for the 10 pound ball to hit the ground. Then v1 over v2 is equal to t2 over t1. So 1 over 10 is equal to t2 over t1, or you could also look at it as t1 is equal to 10 times t2. This is to where the heavier object will reach the ground first because of its weight, although Aristotle forgot to include air resistance and if there was a vacuum, so a fault formed in his theory. Now for Galileo, let's look at uniformly accelerated body. Velocity would equal acceleration times time, to where the acceleration is the constant, and the distance, d, would equal v final minus v initial, the change in velocity, times the time. Now Galileo took into account that air resistance was a deciding factor in which the object would fall first. He used inclined planes, which reduced the time and wind resistance issue. In this clip, we have created a vacuum. Now, when you turn the tube, you can see that the feathers and the penny fall at almost at the exact same time. Now this isn't a perfect vacuum, but we have removed most of the air in here, and so as you can see, this creates a really good effect because they fall at almost exactly the same time. Aristotle believed in a system that consists of thought based on fundamental assumptions that one cannot doubt, a famous truth regarding a derived logic without observed facts, and is seen best as a logician. In 1597, Galileo used his great knowledge to aid the military in creating a compass to aid artillery raids and army formations. Galileo had then created a telescope. He had wanted to test the theory of Copernicus, so he decided to acquire an eyeglass, which was the telescope. I first believed that this project would signify the end of my complete existence and send me spiraling into the depths of hell that is physics. I was absolutely wrong. I guarantee you that it is quite the opposite. I really enjoyed learning about Aristotle versus Galileo, and I hope to, in the future, participate in much merrymaking that is doing a PBL project. And thanks for watching Harmony Schools.